All right, so buckle up. We are going to take a deep dive into the world of research design.
Oh, fun.
All thanks to that big ol' stack of papers you sent our way.
Right.
I know. Research design
Yeah.
might sound a little dry,
Mm.
but trust me on this one,
Oh, yeah.
it is the secret sauce.
Yeah.
Behind every groundbreaking study, every mind-blowing discovery,
It's true.
it's like the blueprint
The blueprint, yes.
for building knowledge, and today we're going to decode it together.
We are.
I'm excited.
Me too. It's like
Yeah.
peeking behind the curtain to see
Yes.
how the magic happens.
Yes.
Understanding research design
Uh-huh.
helps you separate fact from fiction.
Absolutely.
Solid evidence from, like, shaky claims.
It's true.
Yeah.
And get this. We're talking about
Okay.
not one, not two, but three
Wow.
major types of designs.
Okay.
Single factor, factorial, and quasi-experimental.
Okay.
It's like choose your own adventure
I like it.
for scientists,
That's a good analogy.
and we're going to explore all the paths.
Let's do it.
I'm so excited.
All right. Well, just to show you
Yeah.
how impactful these designs can be
Mm-hmm.
in the real world, we'll even touch upon
Okay.
a fascinating study.
I love a good study.
Yeah.
Lay it on me.
About deep-sea divers and their memories.
Oh, deep sea divers. Okay.
Yeah, you won't believe what they found.
Okay, now I'm really curious.
Yeah.
All right, let's start with the foundation.
Okay.
Single factor design.
All right.
Think of it like building a simple house.
Okay.
You've got your foundation, your walls, your roof.
Gotcha.
In research, the foundation is the research question.
Okay.
What are you trying to figure out?
Mm-hmm.
Then you build your design around that question.
So true.
Mm-hmm.
And just like a good house needs solid walls,
Yes.
a good research design needs to control
Okay.
for all those pesky variables
Oh, those pesky variables.
that could throw off your results.
Yeah. Yeah.
Think of it like a detective, eliminating suspects
I like it.
to find the real culprit
Okay.
behind a crime.
That's a great analogy.
Yeah.
So how do researchers...
Well, it starts with understanding
Okay.
the key players,
Mm-hmm.
factors, levels, and treatments.
Okay, so let's break those down.
A factor is just a fancy word
Okay.
for the independent variable,
Okay.
the thing you're manipulating in your study.
Okay, so let's say we're curious about whether listening to music helps people focus while they work.
All right.
Music would be our factor, right?
Exactly.
Okay.
And the levels of that factor would be
Okay.
the different variations you test.
Gotcha.
You might have one level
Mhm.
where people listen to classical music,
Okay.
another with pop music,
Okay.
and a third with no music at all.
Ah, so it's like choosing
It is, yeah.
different flavors of ice cream to see
Exactly.
which one people like best.
Yeah.
But instead of ice cream,
Yeah.
we're testing different conditions to see how they affect focus.
That's the idea.
Okay, I'm with you. Yeah.
Now, the treatment
Okay.
refers to the specific combination
Okay.
of factor levels
Mm-hmm.
a participant experiences.
Okay.
So someone in that classical music treatment
Okay.
would only listen to classical music while working,
Gotcha.
while someone in the no music treatment would work in silence.
Okay, so it's all about
It is.
isolating those different conditions to see
Mhm.
what effect they have.
Yeah.
Makes sense.
It does.
Now, our notes mention
Okay.
two main approaches
Right.
within single factor designs
All right.
between group and within subject.
Yeah.
What's the difference there?
Imagine you're testing a new drug
Okay.
to see if it lowers blood pressure.
Okay, got it.
In a between group design,
Mm-hmm.
you have one group of people
Okay.
take the drug
Okay.
and another group
Okay.
take a placebo.
Okay.
By comparing the two groups,
Mm-hmm.
you can see if the drug has a greater effect
Yeah.
than just the power of suggestion.
Interesting. So different groups, different experiences. What about within subject designs?
Within subject design,
Yeah.
everyone gets to try everything.
Okay.
Let's say you're testing
Mm-hmm.
how different colors affect people's moods.
Okay.
Each person would spend time in a red room,
Uh-huh.
a blue room,
Okay.
and a yellow room,
All right.
and you'd measure their mood in each setting.
Interesting.
Yeah,
So you're comparing
you are.
how the same person
Mm-hmm.
reacts to different conditions
Exactly.
rather than comparing different groups of people.
Yes, very good.
Okay, that's interesting.
And this has some advantages.
Okay.
For one,
Yeah.
it's more efficient with participants,
Oh, okay.
since you need fewer people overall.
That makes sense.
Yeah.
But surely there are some downsides too, right?
Oh, of course.
Our notes mention something about order effects.
Ah, yes.
What are those?
Order effects can be a tricky beast.
Yeah.
It means the order in which someone experiences the conditions can actually influence their responses.
Okay.
Think about tasting different wines.
Okay, I like wine.
If you taste a really bold red wine first,
Okay.
a lighter white wine might taste less flavorful,
Interesting.
simply because of the contrast.
Oh, that's so interesting. So it's like your taste buds
It is, yep.
are recalibrating
That's it.
based on what they experienced before.
Exactly.
That makes sense. And
Yeah.
researchers have some clever tricks
They do.
to deal with these order effects.
Yeah.
One common technique is called counterbalancing,
Yep.
where they mix up the order of the conditions
Mhm.
for different participants.
Right.
So some people might taste the white wine first,
Right.
while others taste the red wine first.
That's it.
This helps average out any
Ex-
potential order effects.
Yes.
Okay, that's pretty neat.
Yeah.
So we've got our single factor designs
We do.
with their different variations. But what happens when we want to study
Oh, that's a good question.
multiple factors at once?
That's where factorial designs come into play.
Okay.
They're like single factor designs on steroids.
All right, I like it.
Instead of looking at just
Yeah.
one factor in isolation, they let us study
Okay.
multiple factors and, most importantly, how those factors interact.
Interact.
Yes.
What does that mean in research terms?
Let me give you an example.
Okay.
Imagine you're studying the effects of both diet and exercise on cholesterol levels.
Okay, got it.
You might find that diet alone has a small effect,
Okay.
and exercise alone
Yeah.
has a small effect.
Okay.
But when you combine a healthy diet with exercise, you get a much bigger reduction in cholesterol
Wow.
than either factor alone would have produced.
Oh, wow.
That's interaction.
Okay.
The combined effect is greater than the sum of the individual effects.
That's fascinating.
It is, isn't it?
So they can work together
Yep, they do.
in a way that you might not expect
Yeah, sometimes it's surprising.
if you were just studying them individually.
Right, exactly.
Yeah, that's really cool.
It's like those power couples.
Yeah.
They're amazing on their own,
Yeah.
but together,
Yeah.
they're unstoppable.
Who knew diet and exercise were such a dynamic duo?
Right.
So how do researchers design studies
Well,
to capture these interactions?
one common approach is a 2x2 factorial design.
Okay.
It sounds complicated,
Yeah.
but it's actually pretty simple.
Okay.
Let's say you're studying memory,
Okay.
like in that classic Tulving and Pearlstone study.
Okay, yeah.
They had two factors,
Okay.
the number of words to remember
Okay.
and whether people got helpful cues to jog their memory.
Okay, I'm following so far.
Yeah,
Two factors.
two factors.
Just like our diet and exercise example.
Exactly, for the number of words. They had two levels,
Okay.
a short list and a long list.
Gotcha.
And for the cues, they had two levels, cues or no cues.
So they basically created 4 different combinations.
You got it?
Short list with cues, short list without cues,
Yep.
long list with cues, and long list without cues.
That's right.
Okay.
And by testing people under each of those combinations,
Okay.
they could see how those two factors interacted to affect how many words people remembered.
I bet the results were pretty interesting.
Oh, absolutely.
Did they find any surprises?
Turns out
Yeah.
having cues was especially helpful
Okay.
when people had to remember a long list of words.
That makes sense.
Yeah.
Like if you're trying to remember more.
It's like the cues acted as little life rafts, helping people stay afloat in a sea of information.
It's like having a cheat sheet for a test.
Exactly.
It doesn't help as much
Right.
if the test is super easy, but it can be a lifesaver.
Yeah.
If you're drowning in information.
Exactly.
That's a great analogy.
And that's the beauty of factorial designs.
Yeah.
They let you see how different factors work together
Yeah.
in ways that you might not expect.
Yeah.
Yeah.
This is all so cool.
It is cool.
I'm starting to see why understanding research design is so important.
It's fundamental.
Yeah.
Yeah.
It's not just about memorizing terms.
Right.
It's about understanding how scientists unlock the secrets
Exactly.
of the world around us.
I couldn't have said it better myself.
Yeah.
Yeah.
Now, just like with single factor designs,
Okay.
factorial designs can use those within subject, between subject, and mixed approaches we talked about earlier.
That's right.
Oh, right.
Yeah.
So you could have a factorial design where the same people experience all the different combinations of factors.
Yes.
Or you could have different groups of people for each combination.
Exactly.
Remember that study about deep sea divers and their memories?
Oh, yes.
That was a within subject factorial design.
It was, yeah.
The divers learned and recalled words, both on land and underwater, letting researchers see how the environment interacted
That's right.
with other factors to affect memory. It's like testing whether people are better at remembering things in a library versus a noisy coffee shop. But with a much cooler setting.
Way cooler.
I like it.
Right.
Okay, so that's a within-subject factorial design. What would between-subject factorial design look like?
Our notes have a great example.
Okay.
With a table showing different groups of people experiencing every possible combination of factors. It's a clear way to see how researchers divvy up participants to test those interaction effects.
Makes sense. And what about mixed designs?
Mixed designs.
Those sound extra tricky.
They can be,
Okay.
but they're also incredibly powerful.
Right.
Our source gives the example of a study on gender, alcohol, and risk-taking while driving. Now, you can't ethically assign people to be male or female.
Right.
So gender is a between-subject factor in this case.
Okay.
But you can have the same people experience different levels of alcohol consumption, making alcohol a within-subject factor.
Oh, that's interesting. So it's mixing and matching those different approaches depending on the factors you're studying.
Exactly. It all depends on what you're looking at.
That makes sense.
Yeah.
But let's shift gears now and dive into our final type of design.
Okay.
Quasi-experimental.
Right.
These sound a bit mysterious.
They do have an air of intrigue.
Okay, tell me more.
Quasi-experiments are like the detectives.
Ooh, I like it.
Of the research world.
Okay.
They're often used when it's impossible or unethical to randomly assign people to groups.
So imagine you want to study the effects of, let's say, experiencing a natural disaster on people's mental health.
Yeah. You can't exactly create a natural disaster in a lab.
Exactly.
So that's where quasi-experimental designs come in.
That's where they come in.
They let researchers study real-world situations where it's not feasible or ethical to manipulate the variables directly.
That's right.
How do they do it?
Well,
our notes mention something called the non-equivalent control group design.
That's a common one.
Okay, break it down for me.
Let's stick with our natural disaster example.
Okay.
Researchers might compare a group of people who lived through a hurricane to a similar group of people who haven't experienced a hurricane.
So they're trying to find groups that are as similar as possible.
Exactly.
Except for the factor they're interested in.
Yes, very good.
The challenge is.
The challenge is.
You can never be 100% sure that the groups are truly equivalent.
That's the tricky part.
Maybe the people who lived through the hurricane also had other stressful life events. Yeah, that's possible.
That could affect their mental health.
Absolutely.
So it's tricky to isolate the effect of the hurricane itself.
It can be, yeah.
But researchers have some clever tools.
Oh, they do?
To help tease apart those factors.
They do.
One powerful technique is the time series design.
Yes.
Where they take repeated measures. Before and after an event or treatment.
Exactly.
So in our hurricane example, they might measure people's mental health multiple times before the hurricane.
Yes.
And then multiple times after the hurricane.
Exactly.
Okay.
This lets them see if there's a clear pattern of change associated with the hurricane. Yeah. Even if they couldn't control for every possible variable.
It's like tracking someone's weight over time.
It is, yeah.
To see if a new diet is actually working.
Right.
But instead of weight, we're looking at changes in mental health.
Perfect analogy.
And time series designs can be used.
They can?
For all sorts of things, like studying the effects of new policies, public health campaigns, or even major historical events.
Absolutely.
Wow, that's incredibly powerful.
It is powerful.
I'm starting to see how quasi-experimental designs can shed light on some really complex issues.
That's right.
Even when traditional experiments aren't possible.
Exactly.
Ooh, wait. There's more.
Oh.
Our notes mention several other intriguing quasi-experimental designs.
All right.
One is called
the
separate pre-test, post-test sample design.
Ah, yes.
Okay, tell me more.
That's a handy one when you're looking at changes over time. But can't track the same people.
Yeah.
Before and after.
Okay.
Imagine you're a company trying to measure customer satisfaction.
Okay.
Before and after implementing a new program.
Gotcha.
Now, You can't always guarantee that the same customers will be around for both measurements.
Yeah, people come and go, customer bases change.
Exactly.
Yeah.
So with this design, you measure satisfaction.
Okay.
In one group of customers before the program, implement the program, and then measure satisfaction in a completely different group of customers afterward.
Interesting.
Yeah.
So you're essentially comparing two snapshots in time.
Exactly.
One before the change and one after.
Yes.
Okay.
It's not a perfect comparison, but it can still give you some valuable insights into whether the program seems to be having an effect.
Okay, that makes sense.
Yeah.
Now, I'm curious about the double pretest design.
Okay.
Why would you need two pretests?
This one is all about being extra cautious.
Okay.
Remember, with quasi-experimental designs, you're often dealing with groups that weren't randomly assigned.
Right.
So there could be pre-existing differences that muddy the waters.
So the double pretest is like adding an extra layer of protection to make sure those pre-existing differences aren't skewing your results.
Precisely.
By taking two pretest measurements,
yes,
researchers can see
they can.
If the groups were already changing at different rates before the treatment or event occurred.
That's right.
It's like taking someone's temperature twice.
It is, yeah.
Just to be absolutely sure.
Exactly.
I can see how that would add a lot of rigor to a study.
It does.
Okay.
And it's that kind of rigor that makes quasi-experimental research so valuable.
Yeah, for sure.
Now, before we move on, we can't forget about
the
switching replications design.
Oh, that one sounds intriguing.
It is kind of fun.
What's the switching all about?
Imagine you have two groups.
Okay, two groups.
In the first phase, you pre-test both groups.
Okay.
Give the treatment to one group.
Okay.
And then post-test both groups.
Gotcha.
But here's where the switching comes in.
Okay.
In the second phase, the group that didn't get the treatment initially now gets the treatment.
Okay.
While the original treatment group acts as a control group.
Whoa, that's like a research tango.
It is, yeah.
They're switching roles halfway through.
Exactly.
And this has some really neat advantages.
It does.
For one, everyone gets a chance to experience the treatment.
Yes.
Just at different times.
That's right.
This helps address some of the ethical concerns that can arise when only one group gets a potentially beneficial treatment.
Yeah, it's much more ethical.
And it also strengthens your findings, right?
It does, yes.
Because you're getting data from both groups under both conditions.
I got it.
It's a really clever way to boost the internal validity of your study.
Yes.
Even without random assignment.
Exactly.
I love how researchers are always coming up.
They are creative, aren't they?
With these ingenious strategies.
Yeah.
Speaking of ingenious, our notes mention that even sophisticated designs, like mixed factorial designs, can be used in quasi-experimental settings.
Absolutely.
Remember, mixed factorial designs have at least one within subjects factor and at least one between subjects factor.
That's right.
Our source material gives a great example with a study on caffeine, pain perception, and gender.
All right.
Okay, so caffeine and pain perception are the variables.
Yeah.
How do they fit into a mixed factorial design?
Okay, so
in a quasi-experimental context,
each participant experienced both caffeine and decaf conditions, making caffeine a within subjects factor.
Gotcha.
However, participants were either male or female.
Right.
Now, we can't ethically or practically assign someone's biological sex.
Right.
So gender becomes our between subjects factor.
So you're essentially looking at whether caffeine's effects on pain perception differ between men and women.
Yes.
But you're not manipulating gender itself.
Exactly.
It's a great example of how researchers can adapt sophisticated designs to quasi-experimental settings, allowing them to study complex questions.
That's right.
Even when random assignment isn't an option.
Exactly.
This is all so fascinating.
It is fascinating.
It's like researchers have a whole toolbox.
They do.
Of different designs.
Yeah.
And they're constantly innovating to find the best tools for the job.
Well said.
And one more tool in that toolbox is the counterbalance design.
Counterbalance design.
Those are especially useful when studying things like learning or skill acquisition, where the order in which someone experiences different treatments can influence their performance.
That's right.
So how do counterbalance designs work?
Okay.
Well, I'm picturing some sort of elaborate balancing act.
It's not quite a circus act.
Okay.
But it does involve careful arrangement.
All right.
In a counterbalanced design. Different groups of participants receive the treatments in different orders.
Gotcha.
Imagine you're comparing 3 teaching methods.
Okay.
A, B, and C.
Got it.
You might have one group try method A, then B, then C.
Okay.
While another group tries B, then C, then A.
Okay.
And so on.
So you're essentially mixing up the order.
Yep.
To make sure that one method doesn't have an advantage.
Doesn't have an unfair advantage, yeah.
Simply because it came first or last in the sequence.
Exactly. This helps control for those pesky order effects we talked about earlier, ensuring that any differences you see in learning outcomes are more likely due to the teaching methods themselves rather than the order in which they were experienced.
That's so clever.
It is, yeah.
It's like giving every teaching method a fair shot at the title.
A fair shot. I like it.
Well, I think we've covered a lot of ground here.
We have, yeah.
We've journeyed through single-factor designs, factorial designs.
Yeah. All sorts of clever, quasi-experimental designs. It's been a wild ride.
It has been a wild ride.
I feel like we've earned our research badges today.
I think we have.
But before we let you go,
let's
talk about the bigger picture.
The bigger picture, okay.
Because all this research design talk isn't just for scientists tucked away in labs.
No, not at all.
So tell me.
Well, understanding these designs makes you a more savvy consumer of information.
Ooh, I like that.
Yeah.
So, like, if I'm reading a news article about a study that claims chocolate is the new superfood, I can actually check how they designed the study.
Exactly.
To see if the results hold water.
Yes.
You know what I mean?
Yeah.
So I can look and be like, okay, was it a well-controlled experiment? Did they account for other factors that might explain the results?
Yes.
Or was it just a bunch of people eating chocolate?
Right, exactly.
And hoping for the best.
Right, exactly.
Right.
Yeah.
So knowing about research design is like having a secret decoder ring.
It is.
For all the information out
For all the information, yeah.
that we see every day.
That's a great way to put it.
It helps you separate the real breakthroughs from the hyped up headlines.
Exactly.
I'm starting to feel like a research detective already.
I love it.
But I'm also realizing that no design is perfect.
I got it.
There are always strengths and weaknesses.
Always.
Trade-offs to consider.
That's right.
Like we talked about how between group designs are great for minimizing those pesky carryover effects. But they often require more participants.
That's true.
And within subject designs are more efficient with participants.
Proficient, yep.
But we have to be extra careful about order effects.
That's right.
And then there's the whole world of quasi-experimental designs.
Yeah.
Which are super valuable for studying real-world situations.
Very valuable.
But they come with their own set of challenges.
They do.
When it comes to controlling variables.
Exactly.
So it's all about choosing the best fit.
It is.
For the research question. And being aware of the limitations.
Yes, well said.
And that's what makes research design so fascinating.
I think so too.
Because it's not just about following a set of rules.
It's not just a recipe.
It's about
that a creativity.
Constantly pushing the boundaries.
Yes.
Finding creative solutions.
Absolutely.
To answer those burning questions that keep us up at night.
That's what keeps us going.
Right.
It is.
Speaking of burning questions, before we wrap up this deep dive, I have one final thought for our listener.
I'm all ears.
We talked about how quasi-experiments allow researchers to study things that would be impossible or unethical to manipulate in a true experiment. The effects of a natural disaster or a new government policy.
Exactly. So my question is, given those ethical constraints, do you think quasi-experiments play a particularly vital role in advancing our understanding of complex human behavior?
That's a fantastic question, and I think the answer is a resounding yes.
Okay.
Quasi-experiments give us a window into those messy real-world situations that we can't replicate in a lab.
Right.
They might not give us the same level of certainty about cause and effect as a perfectly controlled experiment, but they provide incredibly valuable insights that move our understanding forward.
It's like piecing together a puzzle, right?
It is.
We might not have all the pieces, but with each well-designed quasi-experiment, we get a little closer to seeing the whole picture.
Exactly. And that's what I love about research.
Yeah.
It's a continuous journey of discovery. And every study, whether it's a true experiment or a quasi-experiment, adds another brushstroke to the masterpiece of human knowledge.
Beautifully said. Well, I think we've reached the end.
I think so, too.
Of our research design odyssey.
It's been quite a journey.
It has. Yeah. I hope you, our listener, feel equipped to tackle those research papers with a newfound understanding.
Absolutely.
And a critical eye.
Yeah, question everything.
Right. Yeah. And remember, the next time you come across a study that makes you raise an eyebrow, don't be afraid to ask those tough questions about how the research was designed.
Yeah, those are the most important questions.
Because knowing the blueprint, is the key to unlocking the secrets of the research universe.
It is,
Keep exploring, keep questioning, and keep diving deep into the fascinating world of knowledge.
It's a fascinating world out there.
And until next time, happy researching.
Thanks for watching. If you found this video helpful, don't forget to give it a thumbs up and share it with your friends. Your support helps us keep creating valuable content like this. And if you haven't already, hit that subscribe button and ring the notification bell so you never miss an update. Join our community for more insights into psychology and personal development. Let's grow and learn together. See you in the next video.